All right, we will, as you can see, I was going to say, we will continue the amino acid structures as it states. And we'll start linking these together tomorrow. And all we're concerned about is knowing these assorted amino acids and how to keep them separate. Because, well, not separate, but the assorted structures. We've got 7, 8, 9, 10, 11, 12, 13, 14. Now, if we had mentioned that right away, well, I wouldn't say right away, but maybe a week before this was to begin, saying you need to know 14 of the 20, that might be or sound like an overwhelming or daunting task. But have you found different ways or to associate these structures and keep them separate? Do you feel you're pretty good at that with what we've discussed so far? And again, I can't state this enough, working on note cards and writing them out and taking that time to write those structures on the paper that you have, and just trying to remember different types of phrases or whatever it is that would help you out to keep them separate. So I think this mark is about had it too. Okay, so probably be looking down at my microphone a lot. I just have one bar left. Okay, so what we've learned so far. Okay, how do we start, left or right?
Two dashes.
Okay. And then whatever's bonded to here is how you keep them separate. Okay. So to keep them sort of structures separate, if we look at our butyl groups, okay, whether there's a methyl group attached here or here, what two amino acids would those be? That's one, and isoleucine's the other. How can you keep them separate? Sorry, repeat that again. Oh, okay. I guess that's not what I would go by. The bigger L. That what if that makes sense to you? That's fine. So
The first or the second. So
right.
it would be a little L or a big L. Big L is leucine. Well, you got it wrote down. Is the middle one leucine, or did I have those wrong?
This one is leucine.
Yeah, that's the bigger L, because the other one would be on top. That's a little L.
Okay, see, I was taking that.
That's what I mean. That's not how I would associate that. And if you have not done it that way, sorry, do not listen to him. Okay? It works for you. Okay?
Big L. That's leucine.
Okay. Well, good. We got that out of the way. Okay.
I see what you're saying.
So then,
Yeah. Big
I
L.
thought you were going.
bigger L.
See,
Okay.
like here, just what I see it, it's like it's either going to be on the first or the second.
Thank you, Mr. Sawyer, but unfortunately we couldn't have you on camera. I did hit pause, so you're not on there. So the anonymous source, and I just gave it away. All right. So I suppose you could do that. The big L would mean leucine, and then if this is a smaller L, that's isoleucine. Okay. That's what works for you. Okay. Does anyone remember what we gave first as a way to keep them separate? And maybe that's what you'd rather go by. Yeah, okay. So since this is on the second one, that makes that leucine. So isoleucine would come first. So that's why the carbon would go on there. Whichever way you want to look at it. Big L or little l, okay? That works. Okay.
Isobutyl is leucine
Sure. It is.
for no apparent reason.
Yeah, that's just coming right out of left field, but
Yeah.
that still works. Okay. So, all right. How can we change this to a little more complex one like methionine? Do we have to erase anything? Yes, we do.
The bottom carbon.
Okay.
Put an S there. What is an S for sulfur?
S is sulfur. Okay. That's right.
Another carbon below
Okay. Is that it?
the lines.
Do we believe that?
Yeah.
We should. Okay. So, what is it that you could tell yourself that sulfur comes after the second carbon? I guess there's two ways you could look at it. S is second, but that's not what we said in class. Okay? How many curves are on this S? So since there's two curves, okay, it has to come after the second carbon. Whichever, now we're getting back into the, what do we say, the big L and little l, or isobutyl group, whatever works for you. Okay. The simplest amino acid is what? Glycine. And that would be it right there, correct? Okay. Then we've got alanine. And then for all practical purposes, we'll do it like this. Okay. And I think that's as far as we've made it, other than phenylalanine, correct? Okay. So how would we change that to a phenylalanine acid? Does it still have two hydrogens on here?
Yeah.
Yes, it does. And then what goes on here? Yeah. So there is our phenylalanine. All right, I see we're up to almost 8 minutes. So this will be new material. Okay, on page 601, we've got, okay, we'll do cysteine and serine and threonine. Okay, those all have these in common. Okay, so the first one is cysteine. So whether you want to put a dash here or an H means the same thing. Okay. So that is cysteine. Okay. And one of the aspects that we'd want to associate this with is, think of a Renaissance painter that painted a chapel called what? The Sistine Chapel. Okay, so since this is called, I think would you pronounce that? It's Cysteine, so I think it would be cysteine. So what? I don't want to break these $5 glasses. Okay. So chances are you're walking through an art gallery, the Sistine Chapel. Is it noisy or quiet, do you think? It's probably very quiet. So we go, shh, it's the Sistine Chapel. Why would we say shh? Now whether teachers still do this, going shh, like that. Why would that be a clue that this would be cysteine then? Yeah, because you have SH there, okay? So whether you choose to put an S and a dash or an S and an H means the same thing. Okay? Then, let's see here. Get a, not the cysteine is probably a little more complex than this one, I would be led to believe. But now we've got serine. I think it's SER. Is that correct? Yeah. Serine, maybe. I don't know how you want to pronounce that. So probably not the best way to look at this. Okay. I see this is blinking, so just wait a moment. Okay. Now we're back at it again. Like I said, probably not the best way to explain to high school students, but if something is serene, maybe is that an adjective for calm, maybe? Now, I thought it was. Okay. So if something is very serene, okay, if you're 21 and older, okay, what type of group is that? It's an alcohol group, okay? So keep it really simple and serene, and you've got an alcohol on there, okay? Like I said, if you're 21 and older, that's why I said maybe it's not the best way to look at this for high school students, but that's just how I look at it, okay? If something is very serene, it's calm because we're talking about alcohol, okay? Well, is it?
That's appropriate.
It's probably more appropriate than mine, and that's what?
Yeah, Serene, think of Serena, every time she's playing tennis.
Okay,
Oh, every time. They got that little,
okay.
their noise, you know what I'm saying?
Oh, you said, oh.
Oh,
Oh, okay.
it's like you're watching Serena.
Yes. Okay, yeah, well, that works too.
I just know I'm gonna forget what it is, and then on like on the test, I'm gonna be like,
Yeah.
At her appointment.
oh.
Okay, then what happens if we put a methyl group on this one? Now what do we got? Starts with the T. Now we've got threonine. Okay. I just look at it this way, maybe. 3 sides, triangle, so it's threonine. That's just the way that I look at it. Now, a lot of these, if I'm not mistaken, perhaps have very similar, maybe they're all the same suffixes. They all end, that's what I thought, they all end in INE, so that could, I don't think you really want to go by that, I guess. I don't know. A lot of it is just, per se, practice more than anything else, and having a lot more experience than this to myself. And I guess I always look at it the same way, and farmers can relate to this. If you are, well, someone in my case, when I was growing up, if you're backing something up that does not have a swinging front axle, it's really easy to do, okay? But if you're backing something up with 4 wheels that has a moving front axle, it's a little more difficult. And I think you would agree with that, Mr. Ben.
Yeah.
But you're probably better at it than I am, okay?
It's pretty quick.
It does, and I think the clue is you got to look at the back of the wagon. That's not the front. Look at the back. I think that's perhaps what happens. I don't know. That and the tongue, okay? So, with that, I know you made reference to Mrs. Preheim, and what would that entail? Put all these different amino acids up here. Maybe we could just pick one at random, and you come on up here because we've got 10 of them so far, right? 7, 8, 9, 10. Okay? That is correct. We just have 4 left. So you tell me,
Are we on what's the last one?
tyrosine? No. The next two are asparagine or asparagine and glutamine. Okay? So we'll go ahead. Did you want to stop there and practice them or do the next two? Do all four of them? Okay. All right. So with this one then, now this one is asparagine, I think. Is that? Yes. Okay. So then we've got CH2. Okay. And then, oh, not, those aren't methyl groups on there. Then we've got, what is it, nitrogen? I think. Oh, okay. It's another carbon with a double bond of oxygen, then a nitrogen. I think that's right. Yep. Okay. And I think we would agree these last four are probably going to be the more difficult ones. Now again, this one was ASP, I think, is that what it is? No, AS. Because these do have abbreviations, so I don't know if that helps when you look at the book. And then the next one. Sorry? No, I would prefer just giving you the full name of the amino acid instead. And then finally, glutamine. So here again, if you can remember like leucine and isoleucine, for instance, serine and cysteine, okay? They're just a little more complex. This just has one more carbon in it. But if I'm not mistaken, what happens then, since it has one more carbon, we just put one more down here like we just said, and then gesundheit. Okay, and then now we've got, is it GLN? Yeah, glutamine. So GLN for glutamine. Okay. So again, for these are really close together as far as what their structure is concerned. And then once you have one of them down, again, I just go by alphabetical order. And this one just has 2 carbons on it. And then, as you can see, glutamine has 3. That's just the way I've approached it. Okay? Because to me, I think these are probably the hardest to keep separate. Okay? Then, as stated, the last 2 are aspartic acid and glutamic acid, maybe. Okay? So anytime you're looking at an acid, anytime you're looking at that, I think that's correct. Okay, we've got CH2, C, and then OH. So CH2, CO, OH. Yep, that would be correct. That is aspartic acid. Okay, and then since the A comes before G for glutamic acid, how would we change this aspartic acid to glutamic acid? Yep, you're just adding another carbon. Okay. Oops, that's not right. Just thought we'd mix things up there. Because it doesn't really matter which side the double bonded oxygen's on. Okay. So now we have glutamic acid. All right. So associations and I would say memorizing structures, that's the best that we can. I don't know how else to go about this. We spent a lot of time on this in college. Well, didn't seem like a lot of time, but yes.
So we don't do tyrosine at all?
No. Nope. And it's one of those aspects to where, holy cow, you get down to some of these that are a little more complex, like, for instance, lysine and arginine and histidine. Some of those are pretty complex to try to remember. Tryptophan is another one, proline. Those are just way too complex. We want to be able to have a knowledge base to where these are just very minute changes as far as associating these structures. Okay, that's really all I have unless you have something else to add. So we will start linking these together tomorrow. And that does not sound as bad as you might make it out to be, because this follows the very similar pattern to what do we want to say, when carboxylic acids react with alcohols. It follows that same path. Not that we remember that from a couple months ago, but it follows that pattern. So we'll talk about that tomorrow. Catch up to you, or should we say tune in next time. We'll see you then.